So you're very welcome to today's webinar, Simplify 5G Deployments, Let's Talk Tri-Sector Antennas. My name is Anne-Marie, I'll be your moderator today. I'm pleased to introduce today's speakers. We have Fergal Lawler, CEO of Alpha Wireless, who will be providing an overview of tri-sector antennas. Next, we have Luke Kyo, Telecoms Industry Analyst, who will provide insights into the operator landscape and pain points. And we have Colin Cunningham, Managing Director of Cellnex Ireland, who will share with you how they've deployed tri-sectors in Ireland, and he will give a snapshot about their future development plans. So a little bit of housekeeping at the very start. We'd love to hear from you. So if you have a question, please place it into the Q&A tab at the bottom of your screen. We will be answering questions at the very end of the webinar. And if we don't get to yours, certainly we'll follow up with you afterwards. And we'll be launching a poll, so that will be starting in a few moments, and you can vote throughout the webinar on that poll. So without further ado, I'd like to start by welcoming the CEO of Alpha Wireless, Fergal Lawler.
Great, thanks Anne-Marie, and thanks to everyone for joining the webinar today. So I'll give a kind of a very high-level overview on tri-sectors. So basically, to start off, the tri-sector antenna has three separate sectors containing a slimline cylindrical housing. These tri-sector antennas greatly improve the aesthetics of the site, often allowing operators to add capacity where no other options are available. So looking at here in the picture, you can see that the tri-sector antenna is sitting on top of the pole here. It's at, say, 15 meters up, approximately 15 meters up, and the radio is in this cabinet down on the bottom of the pole with the feeders all running up the inside of the pipe. So this is kind of blends nicely into the background. The passing traffic barely notices these are there, and if they do, a lot of the times they don't realize what it is that doesn't stand out. And these tri-sectors can be configured as single operator sites or multi-operator sites. It depends on country and location. So I'll go through some of the kind of the applications of tri-sector antennas. So they're typically used, say, flagpoles, street works, rooftops. But a lot of the big advantages often comes when you're trying to add capacity into areas where residents won't accept kind of unsightly structures. If you look at here, this middle picture, this is kind of Johnny Fox's pub in the Dublin mountains. So probably anyone that's been to Dublin probably is familiar with this. You know, it's in a kind of a nice remote, rural setting, very scenic, but the coverage has been awful. So the only way to get kind of coverage in there is with this kind of low visual impact tri-sector antenna without upsetting or causing problems in the neighborhood. Similar type scenarios, if you look here on the right, you have, and this again, a historic building in Glasgow, a protected building. And the only type of solution that it would accept is a tri-sector type antenna on their rooftop that you can't see from the ground. And then if you look at flagpoles, again, it's probably self-explanatory on flagpoles, but again, it's a typical application for tri-sector antennas. So I'll walk through how it works. I think the best way to just go through how it works, I'll just kind of go through the typical configuration of a tri-sector antenna. And this will help understand how you can configure these for your own particular needs if you're an operator. So to start off with, we look at kind of an exploded view of the tri-sector. If the radon's removed here so you can see what's going on. So you see that, as mentioned earlier, there's three individual sectors. They have, you know, this one here looking at 0, 120, 240 degrees azimuth orientation. That's some of our models allow these to be adjusted, but that does increase the diameter, and they're all tucked in around the center metal spine. This particular model here shows the 3.5 gig AT&R beamforming antennas on the bottom. These support, say, 5G N78 or CBRS Band 48 in the US. So next, you're looking at, we add in the low band, mid band sectors. Again, three sectors wrapped around the pole. And these are multi-band sectors. So the low band covers this, say 617 to 960, and your mid bands can go from 1400 all the way up to 2690. So in this configuration, two operators can share the same antenna. Like an example of this would be in the UK, where you have operator like H3 using 1400 to 2400, and EE can use 1710 to 2690. So looking at the picture here, you can see this kind of a very modular building block approach we use when building these tri-sectors. So it allows us to easily customize the internal sectors depending on what the end customer requirements are. So then this whole the structure then, the cylindrical radome slides down over the top, and then the metal eyelet bolt on top allows you to lift this to the rooftop or pole tops, depending where you're putting them. So here we're just showing that down in the bottom of the antenna you got the three removable access hatches. So you got this allows you to get access to the connectors when you're going onto the feeder cables. So when this is being rigged, there's kind of companies like, say, Delmac Engineering in Ireland or Hutchison Engineering in the UK that have developed very slick processes for running cables up the centre of the pole and into the antenna to connect up to the connectors. It's still very challenging to get that many connectors. Some of these might have 50 feeders running up the pole. So with the recent kind of introduction of cluster type connectors such as M-Lock, greatly simplifies this process that when you got so many connectors on this particular type of antenna. So when you're looking at the kind of the finished unit, you're looking at, say, this is ready for the pole now. It's got the access hatches attached. Inside here, we've already shown you got your 5G, and on top then you got your low band, mid band sectors. And this all fits in a very, very low form factor. So it's 360 millimeters diameter, just a little over 14 inches. So making it the smallest form factor of this type of antenna that's on the market today. Okay, so if you're a network operator and you're building out your network, so if I choose tri-sector antenna. So in the current environment where remote working and remote education are now considered essential, we must ensure that our communities have capacity to make this all possible. So this involves building sites a lot closer to where people live. And traditionally, this would end up in a big battle where the residents are not going to accept an unsightly structure in their neighborhood. So with this type of solution, we're helping network operators kind of overcome some of these challenges, allowing them to put the capacity where it's needed without it kind of being a blight on our communities. So just to kind of sum up then, we're looking at tri-sector antennas. So we're saying they're cost-effective and discrete, providing performance where it's needed. So that kind of sums up this section here. I'm going to pass you over to Luke Keogh next, and we'll continue on from here.
Thanks, Fergal. So I'll share my screen now with everybody. Okay, so everybody should be able to see that now. So my name is Luke Keogh, and I'm a telecoms industry analyst, and today I'm going to be walking you through some of the challenges associated with mobile network densification and how those challenges are pushing operators towards the tri-sector solution that Fergal has mentioned. So one of the key questions that people have is why densify? Why should mobile operators densify? And in general, densification is being driven by the trifecta of increasing demand for mobile network resources, which is due to the demand side factors such as video streaming, due to the use of mid and high band spectrum, which has higher path loss, and then also due to the need for infill coverage. So infill coverage is required in rural areas, and both in rural and urban, in fact, In rural areas, it's been fulfilled by the deployment of new sites with low band spectrum. So in the US, for example, we've seen the new T-Mobile deploy the 600 megahertz band quite extensively. And here in Europe, the 700 megahertz band will be the primary medium for low band coverage. And we've seen in Germany, Vodafone is testing dynamic spectrum sharing between the 700 megahertz and 800 megahertz bands. And even in urban areas, infill coverage is required to provide good indoor coverage where there may be poor indoor signal quality. And this is often caused by new insulation materials and low E glass, for example. Of course, the crux of the reason why operators are pivoting to densification is to unlock additional capacity. So by subdividing cells, you can increase the amount of traffic that each hertz of spectrum can carry. And this then also compensates for the higher path loss with with this spectrum, and it provides more contiguous coverage. And Fergal mentioned about the strain in residential areas, in particular during the coronavirus pandemic, because of the fact that the population has been concentrated there. So that's why densification will be required in those areas. And in the center of your screen here, you'll see an example of an outside-in network design in a rural village in Ireland. And we can see in the orange circle, that's a macro site that's located kind of on a high point. And this is the traditional way operators would have provided coverage into an urban center, but that will not be compatible now with the mid and high band spectrum that's going to be used. So what are the challenges that are associated with densification? So one of the key challenges that is associated with densification is aesthetics. In sensitive urban and suburban, and even in particular residential districts, aesthetics is a huge challenge. So on the left here, we can see freestanding lattice and monopole structures. And both of these have been used by operators for decades because of the fact that they provide good height, which provides a large coverage area. And enough space for the co-location of equipment of multiple operators. So the panel antennas, the remote radio heads, and so forth. And this prominent height, though, also detracts from the visual look of it. So it's visually pollutant. So the prominent height often will protrude into the skyline, and it doesn't conform with other vertical features in the landscape. And this lack of conformity is very difficult to conceal with different concealment solutions. So oftentimes, particularly in the US, we've seen operators use different concealment solutions like paint or like screening with vegetation or with faux water tanks, even faux trees or reflective films. And this adds cost, it adds time, and it's difficult to do with structures that look like this. And all of this then combines and leads to public opposition. And public opposition, of course, slows down the deployment process. So here we see an example of two different stealth solutions that have been deployed. On the right, you can see it's an example of a poorly implemented solution. It's a monopole structure. It's quite tall. It doesn't conform with the height of the trees below, and it's visually pollutant, even though it would have added cost to the deployment process. So it's difficult to conceal these monopole and lattice structures, and that's the message that I'm trying to convey here. And then, of course, as mobile operators move to densification, the role that municipalities or local authorities play in that process is going to become very important. So at the minute, municipalities are in search of an equilibrium or a balance point between promoting economic and social value and minimizing visual pollution through minimizing kind of additions to the landscape. So this is a delicate balancing process, and it's going to become more difficult moving forward. So obviously planning and gaining zoning approval is a huge challenge with traditional sites. There's a huge degree of fragmentation across municipalities, both nationally and internationally. So while a site may be accepted by one municipality, it may not be accepted by another municipality. And this places a huge burden on the mobile operator and on the infrastructure providers, because they have to approach each municipality on a case-by-case basis. It adds time to the deployment process, and it adds cost as well. And obviously, as we move forward, the need to access municipality-owned assets is going to become really important. So a municipality may need to provide ducting for fibre for backhaul, and they may also need to provide access to their street assets for the deployment of small cells and these trisector antennas. And there is quite a positive momentum on this note in Europe. For example, the European Commission has passed Article 57, which is a new EU directive, which is opening up street furniture to mobile operators for deployment of infrastructure such as small cells. So there is positive momentum there. And of course, I'd love to be able to go through all the challenges, but in this short space of time, I don't have enough time to go through all the challenges. So I've summarized some of them here. So obviously space has been exhausted in urban areas, particularly in residential areas. And oftentimes rooftop sites aren't a good alternative or substitute for macro sites because of the fact that residential buildings in a lot of places tend to be quite low and they don't provide the necessary coverage that is required. And of course, cost of deployment is a key concern for mobile operators, as ARPU, or average revenue per user, is stagnant or declining in a lot of markets, and therefore cost, both upfront and long term, is an important consideration. In some markets, there are very strict EMF limits, and this is accelerating the need for densification. So in Switzerland, for example, the EMF power limits are 100 times stricter than those in typical European levels in terms of watts per square meter. And this means that providing indoor coverage with the existing macro cell grid is very difficult with mid and high band spectrum. And that's exacerbated by the use of dynamic beamforming and adaptive antenna arrays with 5G. And then all of these challenges then feed into the fact that the site selection process is multifaceted. So a number of different criteria play in. So the aesthetical would be obviously the visual pollution, the visual impact, I've mentioned that. The technical then would be the performance, capacity requirements, coverage requirements, and economical, the time, cost, the time and cost. On the right of your screen, you can see an example of a replica telegraph pole, and that was deployed in the UK market by Hutchinson Engineering. And mobile operators are have moved away from that design because of that technical criteria, because there's a need for multi-band antennas and there's obviously a need for a larger shroud there to support multiple radio access technologies, and that's why there's a need. They're moving away from that. So just to finish up then, I'm going to leave you here with a comparison table. This just plots the different use cases and how the different site types compare in a color-coded table. The main message I want to convey is that there's not a one-size-fits-all solution in the market, but that each solution is complementary to one another, and they each have a role to play as we move forward and mobile networks become more dense. So with that then, I will finish up there, and I'll pass you on to Colin Cunningham, who's the Managing Director of Cellnex Ireland.
Thanks, Luke. And first of all, thanks Fergal and his team for inviting me today. It's a pleasure to be part of the webinar. I'm going to start off just by giving a very quick overview of Cellnex Ireland. So the company was formed in 2015 following the acquisition of the Quilcha Telecoms portfolio. And then the company was acquired in September 2019 by Cellnex, so we're now part of the Cellnex group of companies across Europe. Today we're operating 600 sites across Ireland, so we have sites in every single county of the country. And I suppose our key focus over the last 5 years has been to deploy new infrastructure, mainly focusing on areas where the coverage was poor in terms of mobile and broadband coverage. And another part of our focus had been upgrading and replacing existing sites. So what we found with the deployment of new technology, a lot of the existing sites that are there today just they're not capable or not possible to I suppose take the equipment or to manage to support the equipment that's required in terms of new antennas and RUs. So our focus has been very much on the new site deployment in areas in every part of the country. And that is in urban, rural and suburban locations. So it's not specific to any particular area. The three methods in which we've managed to do that are with, number one, the traditional method, which Luke has pointed out there, which is putting in planning applications for tower, the traditional lattice structures or the monopoles. And then the second one is trying to find an appropriate rooftop in an area where we're trying to solve the problem. And then finally, the streetwork solution is something that's very new to what we're doing and has been developed in partnership with Alpha Wireless. So I'm actually quite lucky that I live quite close to where Alpha Wireless have their main headquarters down in County Laois. And I've been following the progress that Alpha Wireless have made since they established their company in the early 2000s. And what we're doing here in Ireland is part of, I suppose, getting access to the learnings of Alpha Wireless in other markets. So what we're doing is not necessarily very new, but the application to the Irish market is certainly very new. We're getting a huge insight from the Alpha Wireless team in terms of what they're doing in other parts of the world. But the key to the whole development of the tri-sector solution and applying it to the Irish market has been the engagement of Alpha Wireless and our customer, because obviously each market is different. The spectrum allocation is different in every market. So, we need that engagement to sit down and to develop a bespoke product for the Irish market. And in fairness, the team in Alpha Wireless have worked with us for the last 18 months to 2 years. And we successfully now delivered a number of these tri-sector solutions in the Irish market in areas where I would say we literally had no other option but to deploy such a solution. Our commitment over the next 5 years is to roll out an additional 500 sites, a minimum of 500 sites. And following the acquisition of Cellnex last year, we're now in the process of diversifying our business into other areas, including DAS, bringing fiber connectivity to all our towers. And then we're also looking at the whole area of small cell deployment and facilitating the rollout of IoT networks. So I'm going to bring you through a couple of examples where the tri-sector has been applied. So this picture here shows you it's an area in the city of Cork. The customer request came from Air Mobile, and the objective here was basically to try and upgrade an existing site. So there was an existing site at this location. It was a rooftop installation. The height was very poor. I think the initial height was about 5 or 6 meters off the ground. And the space available to do any enhancement was virtually non-existent. So we didn't have a huge amount of options available in the target area. There was very limited ground space available, and we decided in the end to deploy the streetwork solution with the tri-sector antenna. And as you can see there as well, the backhaul in this particular site is being delivered via fiber. So it does fit in quite well in the area. There are street assets in the local area. There's some there's street lights, and then there's obviously the council camera, security cameras as well. So it does fit in quite well. There is the capability, you can see there on the top of the pole structure. There's a small little arm, and if it was necessary that we needed the wireless backhaul, you can actually put a transmission link dish on the pole, and you can bring the backhaul to the site in that means. The second example here is a site in Dublin, and this again was another request that we had from Air Mobile, and this particular area was actually targeting new coverage. So there was no existing site in the area, so it was a brand new coverage area for Air. Again, quite a residential area. There was some commercial buildings available, but as you can see from the picture there, the commercial buildings that were available were actually underneath the level of the road. So using the rooftop available in the area was really not an option because the height was not there. And this particular solution is deployed as a 12-meter solution. And because of the elevation of the road, we didn't need to go any higher than that. So it's again providing an enhanced mobile coverage to the area. Once again, there's fiber footprint on the ground, so we were able to use the fiber as a backhaul. And you know, we are looking at the option. There is an opportunity here. This particular site could be upgraded to support an additional operator. There is footprint on the ground, as you can see from the photograph, for an additional cabinet, and the pole itself can be easily swapped out and upgraded with a different type of antenna. Here's a couple of more examples of sites that we've deployed in different parts of the country. Right now, today, we've been working over the past 2 years in developing this process. We certainly believe that we've now industrialized the process from the initial stage of the site confirmation right through to the build completion. And today we deliver everything, including the property acquisition, the site drawings, the planning consent, you know, supplying all the materials, integrating the Alpha wireless antenna into the pole, doing all of the active installation of the cables and bringing the power supply, and in most cases bringing the duct infrastructure to connect to the local fiber network. We certainly believe that this is a very cost-effective solution. We look at the deployment we have of towers, monopoles, rooftops, and we do believe that the tri-sector solution in a streetworks context is a feasible solution to be deployed. And as Lucas pointed out there, it's certainly in urban settings and other areas can be very, very fitting with the environment in which we're trying to cover. The key to the success of this is working with Alpha Wireless and coming up with a bespoke antenna that meets the operator requirement. So, you know, our customer obviously has a requirement that we need to make sure that technically we can meet that. And I think, as Fergal has pointed out there, inside the canister or inside the main covering on the antenna, you can put multiple bands, you know, configurations, and there is some flexibility in the azimuth. Obviously, you have to take all the considerations into consideration in terms of the size that you end up with, and then in terms of the environment that you're deploying it. But right now, today, we've deployed this type of solution in rural villages, dense residential areas, and also in commercial zones. What we have found is the minimum height needs to be about 15 meters in order to clear the surrounding clutter of trees and buildings. Here's a picture of the deployment. We've tried to minimize, again, the time. We've tried to minimize the effort. And as you can see, everything is, the foundation is precast off-site. The site works are done, and literally it's a 1 to 2 day on-site deployment. And it is quite quick, and we're constantly trying to evolve this to try and make it better. And then in terms of our future roadmap, we see a number of areas where we're already developing. We're looking at a single footprint cabinet and pole. As Lucas rightly pointed out, some of the areas that you're trying to deploy, the actual space on the ground is very, very tight. So we're trying to integrate the cabinet and pole in the footprint. We do have this product available now, and we're in the process of actually deploying our first prototype in the next couple of weeks. The second area that's under review is a multi-operator solution. Fergal has mentioned that they're involved in the UK in particular. We're watching, you know, the developments there. There is an antenna that's been now agreed in the UK. It's been rolled out for a long time, and we certainly we want to learn from that, and we want to bring that learning to the Irish market. But it does take a lot of stakeholder engagement. It needs the operators to engage in the process, and I think what we found in our own experiences, Alpha Wireless are very keen to sit down with us and to work through that process. Another area that we're looking at, the tri-sector in itself, is deploying it in planning sensitive areas for rooftop deployment, and maybe even going for, full planning for a higher structure in areas where it is very, very difficult. And then the last area that's under review then is an integration of a 5G element into the antenna design. So today we've not deployed any 5G sites in Ireland, but that is something that we need to look at as we go forward. So I'm going to hand back to Fergal to do a final wrap on the webinar. So thank you.
Thanks, Colin. Look, we've probably just gone past our 30 minutes, so I'll just quickly do a 1 minute wrap up. So just to kind of summarize on our antenna, so we're basically saying our tri-sector antennas are cost effective and discreet, providing performance where it's needed. We collaborate very closely with our customers, give kind of full access to our trusted technical team. Our modular approach allows us to customize the solution to meet what the customer needs. We move fast. We typically go from concept to completion in 90 days. So we welcome the new kind of ideas, the new challenges, and we'll resource it. So look, after slipping by our time, I'd just like to say that today's webinar is available on demand on the Alpha website, and it will also be emailed out to people later today. So thanks everyone for their time and their participation and the questions. Any questions that we didn't answer, we'll come back to you after the call. Thank you.